Good morning, student. I am Vijay Aithekar, Faculty of Education and Methodology, Assistant Professor, Department of Physics, JVWU, Women's University, Jaipur. Today, I am delivering my video lecture on energy balance equation in subject modeling and simulation analysis, and in discipline FBT 9 trimester and B.Sc FBT 9 trimester. As we know that energy, what is energy? In previous lecture we have learned about energy. What is energy? Energy is the form which can be transformed from one form to another form. In general, energy are generally classified in three types, or generally two types: kinetic energy, potential energy. In this video lecture, I will be explain some learning objective about energy, or explain and discuss about energy balance, energy intake, and energy expenditure. So, what is energy? Generally, energy are divided in three basic or three general form, or energy has three components. They are, I will be explain step by step. First, kinetic energy. The kinetic energy can be described due to translation motion of the system as the whole relative to the frame of reference, usually earth surface, or to rotation of the system about some axis. In text, we will deal only the transactional kinetic energy. Second type of energy is potential energy. As we know that kinetic energy is given by formula kinetic energy equal 1 by 2 mv square. Potential energy is the energy due to position of the system in the potential field, such as gravitational, electromagnetic field. In this text, we will deal only the gravitational potential field. And third type energy is all energy possessed by the system other than the kinetic potential energy, such as energy due to motion of the molecule relative to the center of mass of the system, the rotational and the vibrational, and the electromagnetic interaction of the molecules, and the motion and the interaction of the atomic and subatomic constituents of the molecules. Suppose a process of system is closed, meaning no mass is transferred according to the boundary. While the process intake take place, the energy may be transformed between such as the system its surrounding in two ways. First, heat, and second is work. Heat. The energy that flow is the result of temperature difference between a system and its surrounding. The direction of flow is always from higher and at higher temperature to lower ones. Heat is defined as the positive when it is transformed to the system from surrounding. Second form is work, the energy that flows in the response to any driving force other than the temperature difference, such as force, torque, voltage. The work is defined as the positive when it is done by the system on the surrounding. The force in the distance is measured in joule, Newton, or diameter. The energy unit also defined in the terms of the system of the heat must be transformed in the specified water release or rise temperature of the water specified temperature interval constant pressure of the 180 atm. The kinetic and the potential energy. The kinetic energy Eg of the Ek of the object m kilogram moving with the velocity relative to the surface earth is given by 1 by 2 mu square. If the fluid creates the system with the mass flow rate kilogram per second and uniform velocity, then Ek equals 1 by 2 mv square, or Eg may be taught as the rate at which the kinetic energy transported in the system by the fluid. Energy balance, the relationship between energy intake and the expenditure. The energy intake, energy absorbed and maintained by the body, energy expenditure, the energy is used in the circular metabolism or loss from the exterior route occurs when the energy intake matches the energy expenditure. Energy balance equation. The energy balance is percentage equal energy intake in kilocalorie upon energy expenditure into 100%. The energy balance can either nil, no change in the energy status, in the weight, positive, energy surplus, the potential increase in the body weight, and the negative energy deflate and the potential body weight reduction. Energy intake. One component of energy equation. Energy sources CHO, protein, fat, alcohol. Diet measurement tool to estimate energy intake. 24 hours recall and food diaries. Energy expenditure. Other component of the energy balance equation. Energy nutrients CHO, fat, protein broken into tissue cost and other cell activity. 1 kilo our energy amount of heat required to temperature rise 1 kilogram of H2O 1 degree Celsius or 4.18 kilocalorie metabolic rate describe the amount of energy released in the given unit of time. Tool for assessment of energy expended: direct calorimeter, metabolic chamber by measuring amount of gases utilizing produced during the energy metabolism directly with the person enter an insulated room metabolic chamber or specified prep. Mechanism: heat release one by layer water, other the fluid surrounding chamber. The change in the fluid temperature reflects the person energy expenditure. Indirect calorimeter metabolism curve measure VO2, VC2, etc. Mechanism: volume of the CO2 produced divided by the volume of oxygen consumed to yield reciprocity exchange rate ratio is defined by RER. RER used to predict the contribution made by fat and CHO to total energy experiment. Component of energy expenditure EE, the total energy expenditure TEE, C1 release metabolic rate is RMR, C2 is metabolic effect TEA, C3 adaptive thermology. Basal and RMR, basal metabolism rate and rising metabolic rate. BMR and RMR is related to homeostatic, include the energy expended for the cell turnover, resting heart rate, urine production, protein synthesis, nucleic acid, etc. About to 50 to 75% or 60 to 75% of TEE is BMR, RMR respectively. BMR estimation method word basal energy. BMR is BW into 24 hours. BMR is 70 into BW 75 3rd. Harris Bentic formula. Main BMR is 66 plus 30.7 BW plus 5 St 6.8 H. Method 4 FO and WHO equation for male and female it is different as shown in the by equation. BMR comparison, male has the higher BMR to female due to greater muscle adaptive tissue ratio, gender difference in the oxygen consumption VO2, woman consumption 80% what the men consume. Thermic effect of the activity TEA. This is the scattered muscle activity where the more ATV demand require the both muscle construction and the relaxation. Estimation of TEA can be done by keeping the activity long 24 hours per hours thread. Thermal effect food TEA increase the energy expenditure associated with the consumption of food represent the increased TEA attributed to diagnosis, absorption, metabolism, and the storage of nutrition. TEA may be also be influenced by size, larger, more TEA, comparison of male, adopted thermogenesis, the energy expenditure increase even decrease to change in the environmental temperature and exposure of radiant energy that is applicable to travel athletes to the cool environment, etc. Thank you so much.